Good afternoon, everyone. My name is Janeth G. Garcia. I am part of the thermal group, and I am here to discuss the bimetallic strip thermometer. Bimetallic strip thermometer. The amount of expansion differs in various materials. The expansion of certain heated materials can be readily seen, while others expand less dramatically. This is what we call thermal expansion. Most materials expand on heating and contract on cooling. Let us try to understand thermal expansion qualitatively on the basis of molecular theory. Let us visualize the forces between the neighboring atoms in a solid by imagining them to be connected by springs that are easier to stretch than to compress. Each atom vibrates about its equilibrium position. When the temperature increases, the energy and amplitude of the vibration also increase. The interatomic spring forces are not symmetric about the equilibrium position. They usually behave like a spring that is easier to stretch than to compress. As the atoms get farther apart, the dimension increases. Another example of thermal expansion is heating a bimetallic strip. This is composed of two strips of different metals that are joined together, which expand at different rate as they are heated, usually steel and copper, or in some cases, steel and brass. One of the metal is expanding faster than the other because they have different coefficients of thermal expansion. In some applications, the bimetal strip is used in the flat form. In others, it is wrapped into a coil for compactness. The greater the length of the coiled version gives improved sensitivity. The earliest surviving bimetallic strip was made by the 18th century clockmaker John Harrison. He is generally credited with its invention. John Harrison followed his father's trade as a carpenter. Harrison built and repaired clocks in his spare time. Legend has it that at the age of 6, while in bed with smallpox, he was given a watch to amuse himself, and he spent hours listening to it and studying its moving parts. There are two basic principles of the bimetallic strip thermometer. All metals change in dimension, that is, expand or contract when there is a change in temperature. The rate at which this expansion or contraction takes place depends on the temperature coefficient of expansion of the metal. The difference in thermal expansion rates is used to produce deflections, which is proportional to temperature changes. Bulb thermometers are good for measuring temperature accurately, but they are harder to use when the goal is to control the temperature. The bimetallic strip thermometer is good at controlling things because it is made of metal. They are widely used in industry for temperature control because of their robustness, temperature range, and simplicity. How does a bimetallic strip thermometer works? An increase in temperature will result in the deflection of the free end of the strip. The radius of the curvature of the bimetallic strip is determined using the following relationship. R is the radius of the curvature at the second temperature. T is the total thickness of the bimetallic strip. M is the ratio of the thickness of the lower expansion metal and thickness of higher expansion metal. Alpha sub L is the coefficient of expansion of the lower metal, and alpha sub H is the coefficient of expansion of the higher metal. T1 is the initial temperature, and T2 is the second temperature. The following are the important properties a material should have to be selected for bimetallic strip thermometers. Coefficient of expansion, modulus of elasticity, elastic limit after cold rolling, electrical conductivity, ductility, and metallurgical ability. Bimetallic strip thermometers are one of the oldest techniques to measure temperature. They are designed to work at temperatures up to 500 degrees Fahrenheit or 260 degrees Celsius. Some major application areas of a bimetallic strip thermometer include various household appliances such as ovens, air conditioners, thermostat switches, wall thermometers, or circuit breakers for electrical heating devices. Here are the advantages and disadvantages of a bimetallic strip thermometer. Advantages: power source is not required. It is robust, easy to use, and inexpensive. The disadvantages are: it is not suitable for very low temperatures because the expansion of metals tends to be similar, so the device becomes a rather insensitive thermometer. It is not very accurate. It is limited to applications where manual reading is acceptable, and when regularly used, the bimetallic strip may permanently deform, which in turn will introduce errors and inaccurate results. Although the bimetallic strip thermometer has a number of disadvantages, it is still widely used because of its number of practical applications and main features.